Hi everyone. In this video, let's solve Leetcode problem number 1143, longest common subsequence. The problem states that given two strings text1 and text2, return the length of the longest common subsequence. If there is no common subsequence, return 0. Let's try to understand what a subsequence is. Let's take this string for an example, A, B, C, D, E. Now, a subsequence is a new string that we can generate by using any of these characters from the input string with the condition that the order of these characters are maintained as what we have in the input string. Now, let's take these three letters from the input string for an example. If we form a string with only these three characters, the resultant string is a subsequence of the input string as long as the order of these three characters are same as what we see in the input string. Now in this case, A, B, D appears in the same order in the input string, and hence this is a subsequence. Now let's take another example. Letter B, D, and E. Now if we form a string with these three characters in the same order as what we see in the input string, the resultant string again, the B, D, E, is a subsequence. Let's take one example to see what is not a subsequence. Let's take these three characters, A, B, C. Now let's try to form a string with these three characters but in a different order. So let's take this character for example, and then letter A followed by letter B. Now even though this string has all the characters from the original string, because the order is not same as what we see in the input string, this is not a subsequence. Let's take one more example to understand what is not a subsequence. So let's take these three characters now. Now let's try to form a string with these three characters but in a different order. So the resultant string CED is not a subsequence of the input string, mainly because the order of these characters are not the same as what we see in the input string. Now let's get back to the problem. The question states that given two strings, we need to find the length of the longest common subsequence. So we are just going to return an integer, which is the length of the longest common subsequence that is possible with these two strings. Now, a brute force solution would be to just find all the possible subsequences for the two strings and then get the common subsequence and then find the max of the common subsequences. But such a solution would be order of n square, and we can obviously do better. Let's take the first character of these two input strings. By comparing the first characters, we know that these are same. So there is at least one common subsequence of length 1. In each comparison, we're just going to adjust the pointer. Now, which pointer we are going to adjust depends on what is the result of the comparison. If the two characters are same, we're just going to adjust the pointer to the next characters of both the strings. So in this case, our longest common subsequence is going to be of length 1 plus whatever common subsequence that we can find from the remaining characters. So for example, in this case, the longest common subsequence is going to be 1 plus longest common subsequence of remaining characters. So we adjust the pointers of both the strings. Okay. Once we move the pointer, we realize here that the characters are different. Now, when the characters are different, we know that the longest common subsequence is going to be either between this string and the entire second string. Let's say this is our group 1, or it can be the entire first string when compared with the remaining of the second string. So whichever comparison gives us the max, that is going to be our output. So let's say this as our group 2. And hence, if the characters are different, our longest common subsequence is going to be the max of longest common subsequence of group 1 and longest common subsequence of group 2. Again, group 1 is identified by adjusting the pointer of the first string, and group 2 is adjusting the pointer of the second string. So just to summarize, if the characters are same, then it is 1 plus longest common subsequence of remaining characters of both the strings. So we are just going to adjust the pointer for both the strings. If the characters are different, then we are just going to adjust one of the pointers and then find the max of both the groups. This will be clear once we implement the problem. Let's implement the recursive solution. So for recursive solution, we are just going to pass the two strings. Let's say string S1 and S2 and two indexes for corresponding strings. So this, let's say this is index 1 and index 2. And we are just going to have a dictionary object. This will be my cache. Because we are dealing with a dynamic programming solution, we want to cache all the intermediate results that we are going to find for different combinations of index 1 and index 2. This will be clear once we add values to the cache. I'll add more explanation there. So for our recursive, the base condition is if index 1 or index 2 beyond the string's length, then I'm simply going to return. So this is our base condition. This will return 0. Because we know that if our indexes are beyond the length of the string, there is no possible subsequence that we can form. So this is 0. Now for our dictionary, the idea is like this. So let's say we call this LCS function with the index 1 being 4 and index 2 being 5. Right. Now, whenever I call this function, I'm going to calculate this value for the very first time. Let's say, I don't know, this value, let's say this comes to 5, for example. Now, we don't want to do this calculation every time. Calculation as in comparing the characters, calling the recursive function again for the remaining characters in the string. All these calculations we should not do repeatedly. Now that we did for the first time, we just need to add this to the dictionary. And before we do any calculation, we just need to check if the dictionary contains an entry for a combination of index 1 and index 2. If yes, then we will return the value from the dictionary. Else, we will do the calculation. So in this case, I'm just going to construct my key as something like this. So my key is just going to be index 1 and then let's say a delimiter. In this case, it is underscore and then index 2. So this will be my key for the dictionary or the cache, and the value is simply going to be 5. So anytime I have an entry for index 1 underscore index 2 in the cache, I'm just going to return the value. So that's the idea. Now let's say key is index 1 underscore index 2. First thing I want to do, if my cache contains this key. If yes, we are simply going to return that. So this will be the value that we are going to return from the cache. Now, if we reach this line, it simply means that our cache doesn't have an entry, so we are just going to do the comparison. So let's compare the index 1 position of string 1 with corresponding position on the string 2. So we're just going to compare two characters here. Okay, so if these are equal, now if these are equal, my longest common subsequence is 1 plus whatever I get for the remaining characters. So this will be S1, S2, index 1, and just going to increment by 1 because we are moving the pointer. And then index 2, again we are incrementing that, and we are just going to pass the cache. So this value we're just going to add to our cache for now. And for cache, the key is what we calculated. And okay, if the value is not same, then my longest common subsequence is basically max of two longest common subsequences. So map.max of group 1 comma group 2. Right. So group 1, we know that it is formed by adjusting the index of first string. So index 1 plus 1. Index 2, we are not going to touch, or it will be the same. So it is max of this, or we will call LCS function again, but this time we will leave index 1 as it is, but simply increment index 2. Again, this needs to go into the cache. So, okay. Yeah. Now that we added an entry into the cache, all we need to do is simply return the entry from the cache. Okay, this is how our recursive function is going to look like. We need to call this function, and in order to call this function, I need a cache object. So let's declare this. Let's simply pass this object as it is. I'm not going to add any entry into this cache because we don't know at this point what value to add. That will be done inside the recursive function. Then it is going to return whatever this function gives us. So text1, comma text2, and index 1 is going to be 0. Index 2 is going to be 0 because we're going to start with the first character. Right. Let's run this and see if this works. Okay, there is a syntax error, line 20. Let's fix that. Yeah, list of tools brackets. Let's run those. Okay. As you can see, all three cases passed. Now let's submit this. As you can see, the solution is accepted. Now that we have seen a recursive implementation of the problem, let's see how we can solve this using a tabular method. As you can see here, these are our two input strings, A, B, C, D, E, and A, C, F. We're just going to populate this two-dimensional matrix by using the learnings that we had from our recursive implementation. Let's start with the first character. So in this case, the characters are same. So we know that if the characters are same, then it is 1 plus the longest common subsequence of remaining characters of both the strings. So we know that we need to adjust the pointer of both the strings. So which means we will adjust the pointers like this. So we move diagonally down, and whatever we get here, that will be added to our previous cell, which is currently having 1. So 1 plus whatever we get in this cell is going to be our result. Now, in this case, letters C and B are different. So if C and B are different, we know that we need to adjust either one of the pointers and then find the max of the values, which means we will have to find the values for these two cells. And then the max of these two cells will be the value of my current cell. So let's find the value of one of these cells. So let's move to the right. Now here, the values are same. Letters from both the strings corresponding to this cell are same, which means we're just going to add 1 plus whatever we find in the diagonally down cell. So we move down diagonally. So in this case, letters B and F are different. And when we deal with different letters, we're just going to find the two neighboring values and then get the max out of it. So we're just going to find the value for these two cells. Now the one at the bottom, the value is 0 because there's no character for that particular cell corresponding to the string ACF. The string ACF has only 3 characters and we are in the 4th location, which means it is null. And when we deal with null, there is no possible subsequence that we can get out of it. So this length is going to be 0. Now we need to find the value for this cell. Once we have this, the max of these two will be the value of the previous cell. So again, letter E and F are different. So we just need to find the values for these two cells. And we know that these are basically null and hence the value is 0. Max of 2 zeros is again going to be 0. So the value of this cell is 0. Now that we know these two values, we're going to go to the previous cell. And this is nothing but the max of these two cells now. And since both have 0, so we are just going to update 0 to our current cell. Notice that we came to this cell from the diagonally top cell. So we are just going to go there. And because we travel diagonally, we know that we need to add the value here. Because we move diagonally only when the values are same or the letters are same. If the letters are same, it is 1 plus whatever we get in the diagonally bottom cell. So in this case, it is 1 plus 0. So we're just going to update the value to 1. And now we need to find the value for this cell. This cell, if we compare B and F, these are two different letters. So we need to find the value for these two cells and then take the max out of this. And again, the bottom one, we know it is 0 because we are dealing with a null character. So this is 0. And the other one, we are just going to find now. So C and F, these are different characters. So we need to find these two and then get the max out of this. For one cell, we already know the right cell, we already determined it is 0. And the bottom one, we know that it is a null character. So this is again 0. And we simply update the current cell to 0 because these two highlighted cells are 0. And the max of 0 and 0 is simply 0. So we have this value. And let's move to our previous cell. Now that we calculated these two, we're just going to fill this value here. So this will be 0 again. Okay. Finally, we have the value for these two. And hence, the value for the current cell is going to be max of 1 and 0, which is 1. And again, we move to this cell from the topmost cell by traveling diagonally. So we are going to go back and add this value to our current value. And hence, the longest common subsequence for these two strings is going to have a length of 2. And the longest common subsequence in this case is actually AC, which has length 2. Let's see how we can implement this. Now let's implement the tabular method for the same problem. I'm just going to remove this that we implemented earlier. For tabular method, we need a 2-dimensional array, and the length of this array is just going to be the length of the input string plus 1. Remember from the discussion, we needed the extra row and column for the null characters or characters of length 0. Right, now let's also declare our array here. Our array is just going to be your length plus 1 and n plus 1. Okay, now we're just going to start from the last cell of the array or the rightmost bottom and then move diagonally upwards and finally return the value of cell 0, 0. So for that, I'm just going to start from the last column, last row, So this will be m minus 1 because m is just going to point to the null character or the position corresponding to the null character. I'm going to run this as long as I is greater than or equal to 0. I minus plus. And my G or column index is going to start from n minus 1. As long as j is greater than or equal to 0 and minus. Okay. So in this case, there are only two possibilities. So we are just going to compare x1 of I with x of j. This is the row and column index. Now, if these are equal, now if the values are same, because we are going from the bottom to the top, we're just going to pass this value to our top left cell. So I'm just going to update I comma j as 1 plus whatever I have plus 1 and j plus 1. So again, if let's say the characters are I comma j, let's say I comma j is 5 comma 5. Now if the characters are seen, what am I doing here? I'm setting my cell corresponding to row and column being 5 comma 5 to 1 plus whatever I have in the cell diagonally down. And that's the whole idea, right? So we are just going to take the value that we have diagonally down and then add that to my current cell. And remember, we are going from bottom to top. So by the time we calculate 5 comma 5, we already know the value of 6 comma 6. So we're just going to add that to our current cell. And that's the reason why we want to go from bottom to or in the reverse direction. Okay. Now, if the values are not same, what are we going to do? So this will be max of two values, the right and the bottom. This will be max of my right cell, which is column plus 1, or 1 comma g. Again, because we are going in the backward direction, by the time we calculate I comma j, we already know the value of I comma j plus 1 and I plus 1 comma j. It is as simple as just getting the max of these two cells. And yeah, we are done with this. So finally, we just need to return the value that we have in the first cell. That is the longest common subsequence between these two strings. So let's run this solution now and see if it works. Yeah, I missed declaring both ing. So let's fix that, and now let's run the code to see if it works. Yeah. Now let's submit this and see if it works. And so you can see the solution is accepted. Hope this was useful. Thanks for watching.